Hello, this video is all about the introduction to Precalculus for business. In our first video, let us talk about the linear equations and the linear graphs, what we have learnt in algebra. We have seen this type of notations for intervals. If we have a closed interval, say between 2 to 5, when 2 is included, 5 is included, or in general, if it is between A to B, if A and B are included, then we always write that using a closed bracket. We denote that graph using a closed bracket, or the notation will be A less than or equal to X less than or equal to B. The equality sign will be there. If the equality sign is not included, then it means it is open at that point. So in other words, that point B is not included, or A is not included, or both A and B are not included. Maybe we may have all the values to the left of A, which means we have from negative infinity to A, or you can say X is less than or equal to A, or the interval notation will be negative infinity to A, closed at A, open at negative infinity. And we know how the diagram is going to be. So like this, we have already seen this type of notations for intervals. We also might have come across equations in just one variable, linear equations one variable x. The standard form is ax plus b equal to 0. We can solve for x. Like in this example, we have x is equal to 24. Sometimes you may also have inequalities. If the inequality is there, then you always solve just like the one what we did for the ordinary equations, but we preserve the inequality. And here when you are using this division by negative, you know that the inequality sign changes. So in the last step, when negative 2x is less than 8 and when you divide by negative 2, that inequality less than sign changes to greater than, and the notation, the interval notation is negative 4 to infinity, both are open, or you can even show that in the graph as shown in this diagram. When we talk about the straight lines, we know that it is linear in terms of two variables x and y, and the standard form is ax plus by equal to c. The slope-intercept form is y is equal to mx plus b, where m is the slope and b is the intercept. Suppose if I am taking 2 points x1, y1 and x2, y2, then the slope will be the difference between the y coordinates divided by the difference between the x coordinates, or the vertical change divided by the horizontal change, or rise over run. The equation of the line in the point slope form will be y minus y1 equals m times x minus x1. And if you have a horizontal line, that is a line parallel to the x-axis, will be y is a constant, in which case the slope will be 0. If it is a vertical line which is parallel to the y-axis, the equation will be x is a constant, where the slope is not defined. We may come across this type of applications of linear equations. The first one is called the profit-loss analysis. When we talk about the profit-loss analysis, we need the cost and revenue. Cost can be a fixed cost or a variable cost, and the revenue is the income. And if the revenue is less than the cost, then the company loses. If the revenue is equal to the cost, then there is a break even. If the revenue is greater than the cost, then the company makes a profit. If P is the profit, you can talk about P less than 0, equal to 0, greater than 0 for the cost to exceed the revenue, cost equal to the revenue, and revenue exceeding the cost when the company makes a profit. Let's see this example to understand the break even. A university club plans to raise money by selling t-shirts. The charge is $400 for creating the artwork and $3.50 per shirt, which is printed. The selling price is $15. So now we are trying to find how many shirts you need to make the sell to have the break even. So if I want to have the break even, the profit must be equal to 0, or the cost price must be the revenue. Here the cost price is $3.50 per shirt. So if there are n shirts, then it is 350 times n, plus the printing charge is 400. So the equation for C will be 400 plus 3.5 n. The revenue is $15 each, so it is 15n. If it is break even, the two equations must be equal. So when you solve for n in this, you get n is equal to 34.78. It cannot be a fraction. Since we are talking about the number of shirts, it cannot be a fraction. So you go to the next highest. So you need 35 shirts to have a break even. Then the next application is the supply and demand. We call the point of intersection of the two equations, the equation of the supply and the equation of demand, as the point of equilibrium. So we need to find the equation of supply and the equation of demand and find the point of intersection of that. That point is called the equilibrium point. So this is to stabilize the price. Suppose if P equal to mx plus b is the supply equation, and again you can find the equation for the demand. You have to draw the two and find the point of intersection to find the equilibrium point. The supply equation for the supply values are 340, 370, and the price is 2.22, 2.72. So your x is 340, y is 2.22. Your x2 is 370, y2 is 2.72. By taking 2-point formula, you can find the equation of the line, you can find the slope, you can find the equation of the line, or you can even use your graphing calculator to get the linear equation. The same way, for the demand also, you can find the linear equation. So using your graphing calculator stat edit under L1 and L2, you can enter those values. You make use of the linear regression under stat calculation. So you get the coefficients A and B for the supply equation as well as the demand equation. So the first one is your y1 and the second one is your y2. By graphing these two equations, y1 and y2, y1 represents the supply equation and y2 represents the demand equation, you can find the point of intersection, which will give you the equilibrium point. So in a graphing calculator, when you enter those values, you may not see the point of intersection because the calculator has to be adjusted for the window. So when you change your window settings, as shown in this diagram, you may find the point of intersection of the two equations, y1 and y2, to be 299.98 point something, comma 1.519. So the point of equilibrium will be 298 and 1.52. So this means that the common value of supply and demand is 298 million at a price of 1.52 per bushel. So this video is just an introduction to understand how we are making use of the linear equations. Maybe in our next video we will talk about simultaneous equations, maybe equations in terms of two variables, and we will try to solve such equations and we will see the application of those simultaneous equations. We know that we need minimum one equation to solve one variable x. That's what we were looking here. And if you are having two unknowns x and y, you need at least two equations to solve for x and y. Let's see those things in our next video. Hope this video was helpful. Thank you for listening and thank you for watching. Thank you.